All right, let's just jump right into a puzzle that, it seems like it completely breaks the laws of physics, right? We're going to figure out how these massive metal objects can float. And trust me, by the end of this, you'll see the super simple science that makes it all click.
Seriously, think about it for a second. You see it all the time. A gigantic aircraft carrier, we're talking tens of thousands of tons of steel, just floating there on the ocean. But then you just toss a tiny little pebble into a pond and whoosh, it sinks straight to the bottom. It just feels wrong, doesn't it? So, what's going on here? How is that even possible? Well, believe it or not, the answer to this whole mystery comes down to just one single fundamental idea in physics. It's like the master key that unlocks exactly why some things float and why other things sink. And that key idea is called density. Now, the official textbook definition is the mass of a substance per unit of volume. But don't get hung up on the jargon. We're going to break this down. This one simple idea, it's the thing that unlocks everything for us. Okay, so here's a much easier way to think about it. Just ask yourself, how tightly packed is the stuff inside an object? How many little atoms and particles are crammed into a certain amount of space? Are they all jammed in there shoulder to shoulder, or do they have a lot of room to spread out? This is the perfect way to picture it. Look at the brick and the sponge. They're basically the same size, right? But the brick, it's packed solid with stuff. That gives it a really high density. Now the sponge is full of holes, full of air, so there's very little actual stuff in that same space, and that means it has a super low density. So, same size, totally different densities. And every good detective needs a tool to solve the case. Well, for us, our tool is this really simple formula. You'll see it right here. Density, which by the way, scientists often show with that Greek letter, rho, it's just mass divided by volume. That's it. This is the only little piece of math we need to crack this whole thing wide open. Okay, so we've got the concept down. We know what density is. But, to actually solve our big ship puzzle, we've got to know how to measure it. So let's think of this next part as our field work. We're going out into the lab, so to speak, and learning the hands-on techniques to find the density of pretty much anything. So first up, let's talk about a liquid. It's a pretty straightforward process. To get the mass, you just weigh an empty container, then you pour the liquid in and weigh it again. The difference between those two numbers? That's your liquid's mass. Easy. Then, to get the volume, you just pour it into something like a measuring cup or a graduated cylinder. And once you have those two numbers, you just use our detective's tool. So let's say our liquid had a mass of 50 grams, and its volume was 25 cubic centimeters. Well, you just do the math, 50 divided by 25. That gives us a density of 2 grams per cubic centimeter. See? It's really that simple.
Now, what about a regular solid, something like a cube or a block? This is actually even easier. You just pop it on a scale to get its mass, then for the volume, you just grab a ruler, measure the length, the width, and the height, and multiply them all together. Done.
And once again, we just plug those numbers right into our formula. If our little block has a mass of, say, 240 grams, and we calculated the volume to be 80 cubic centimeters, we just divide mass by volume, and boom, we get its density, 3 grams per cubic centimeter. Simple as that. Okay, but what about something weirdly shaped? Like our pebble from the beginning. You can't really measure its length and width. For this, we use a really clever trick called water displacement. First, you get its mass on the scale. Then, you take a cylinder of water and drop the object in. You see how much the water level rises? That amount. That is the object's exact volume. It's a brilliant little hack. So, let's say our little rock weighed in at 150 grams, and it made the water go up by 30 cubic centimeters. We can now calculate its density, and it comes out to 5 grams per cubic centimeter. And with that, our fieldwork is done. We have all the tools we need to solve the big mystery. All right, this is it, the moment we've all been waiting for. We've figured out our main clue, density, and we've even learned how to measure it. So now, it's time for the big reveal. Let's put all these pieces together and finally solve this floating ship puzzle. So here's the solution. The steel itself? Oh yeah, it's incredibly dense, way denser than water. If you drop a solid steel wrench into the ocean, it sinks like, well, a rock. But here's the thing, a ship isn't a solid block of steel. It's actually mostly a hollow shell filled with a whole lot of air. And all of that low-density air inside the hull brings the ship's overall average density way down. The crucial point is that the entire ship, the steel, the air, everything together, as one giant object, is actually less dense than the water it's sitting in. And because it's less dense than the water,
the water can hold it up. That's it. That's the secret.
So cracking the code on the floating ship is awesome, but this idea is so much bigger than just that. Seriously, understanding density is absolutely fundamental to all kinds of science and engineering. So let's zoom out for a minute and see why this one concept is so important in the real world. And yet, it's not just about ships. Density is one of those amazing properties that's just quietly running the world in the background. How does a geologist tell the difference between a chunk of gold and a worthless rock? A lot of the time, it's by checking its unique density. It's the reason a hot air balloon floats up into the sky, because hot air is less dense than the cooler air around it. It's even happening right in your kitchen every time you see oil and vinegar separate in salad dressing. Once you know what to look for, you see it everywhere.
Which kind of leaves us with one last little puzzle to chew on. Think about a submarine. It can float on the surface, but it can also sink down deep on command. Now that you understand the power of changing an object's average density, can you figure out the trick they use to do that? I'll let you think about that one. I really hope this helps you see the world around you just a little bit differently. Thanks for sticking with me on this one.